Hello students, welcome back to my channel. Today I have come with questions based on capacitors and electrostatics. Okay. These questions are in continuation with the previous questions which were asked on the 30th January 2023 JEE mains exam. Okay, both morning evening questions I have combined so that you get at least 4 to 6 questions per topic. Okay, so let us start. This is the first question. As you can see that two isolated metallic solid spheres of radii r and 2r are charged such that both have the same charge density sigma. The spheres are then connected by a conducting wire. If the new charge density of the bigger sphere is sigma dash, then the ratio sigma dash by sigma. So we'll do one thing. We'll proceed in terms of sigma. That is, we'll find sigma dash in terms of sigma and we'll get the ratio. Okay. Right. So let us start. We have two spheres. Okay. One is small, the other is big. So this way you have a smaller sphere and then you have a bigger sphere. I'm not drawing to scale, students. Okay. So kindly pardon me. Okay. Right. So this radius is r and here the radius is 2r. You can see the radius are in the ratio 1 is to 2. So their areas will be in the ratio 1 is to 4. Okay. Their surface areas, I'll call this as first sphere, this as second sphere. So the ratio will be 1 is to 2 square, that is 4. Okay, right. So if sigma is the charge, surface charge density for this, then here the charge will be, charge on this will be sigma into what? I'll take it as 4 pi r square. So automatically here the area is 4 times of this smaller one. So therefore the charge will be 4 times of the smaller one. So Q2 will be 4 times Q1. I hope that is clear. Later we can substitute, don't worry. Now once they are joined together, okay. So what happens when they join together? It is just like connecting them in parallel. So when two bodies are joined in parallel, the voltages across them will remain same because they will attain the same voltage, and accordingly the charges will be in the direct ratio of their capacitance. Here, as you know, for a sphere the capacitance is equal to 4 pi epsilon 0 r. In other words, capacitance will be directly proportional to the radius, so the charges will be distributed in the direct ratio of the radii. So here the radius are in the ratio 1 is to 2. So the total charge will get divided in the ratio 1 is to 2. So in other words, here the new charge on the bigger sphere, new charge here, I'll take this as Q2 dash, will be, what is the total charge? Total charge is Q1 plus 4Q1, that is 5Q1. It will get divided in the ratio 1 is to 2. One part will be taken by this and two parts will be taken by this. Okay. So you have to divide by 3 sum of ratios and give two parts to this. Okay. So therefore now charge will be surface charge density into area. Area is how much? Area is 4 pi 2r square. Is it? Whereas here it is 5 into 2 by 3 into q1. What is q1? Q1 is sigma into 4 pi r square. I hope that is clear, students. So 4 pi r square gets cancelled. Okay. On this side we are left with 4. Okay, 4. So 2 2s are 4. So sigma dash upon sigma will be 5 remains here itself. This 2 goes below this. and is next to 3. So 5 is to 6 is the answer. I hope that is clear. Moving on to the next question. The electric field in a certain region is given by vector E equal to this, the assignments. This is quite simple. This question is based on principle of homogeneity in dimensions. Principle of homogeneity in dimensions simply states that two or more physical quantities which are being added or subtracted should bear the same dimensions. Moreover, the result which you get after adding or subtracting should also have the same dimensions. In other words, the electric field intensity dimensions should match with the dimensions of A upon x square, which in turn should match with the dimensions of B and y cube. Okay, so you know for electric field, as per definition, electric field is the force experienced per unit charge. So based on that, I can say x is what? X are coordinates. So coordinates is basically length. So length means meter. So this will be x square would mean meter square. So meter square goes up. The Newton meter square into per coulomb. Similarly, coming to this, B dimensions of B upon Y will be again in meter. Meter cube will be equivalent to Newton per coulomb. So this will be B will be equivalent to Newton meter cube per coulomb. So B option is the correct option. You can see Newton meter square per coulomb and Newton meter cube per coulomb. Right. Moving on to the next question. As shown in the figure, slightly I'll compress this. As shown in the figure, the point charge Q is placed at the center of the conducting spherical shell of inner radius A and outer radius B. The electric field due to charge Q in three different regions, 1, 2, and 3 are given by. So region 1, as you can see, student, for distance from the center less than A, this region 1, it has been marked in the figure also. Region 2 is within the sphere, I mean between the two surfaces, and region 3 is outside it. Now you know anywhere inside it, because of this charge, there will be electric field everywhere. So lines of force will be there. However, there will be no lines of force within it. Okay. So what happened here? I'm not able to rub this. I don't know why. Anyway, so this is by mistake. Okay, students, this is not there. So this way, lines of force will remain outside the sphere. Within the sphere, it will be there, so electric field will exist. Outside the sphere also, they will be there, so electric field will exist. Inside, it is not there. As you know, there is a term known as electrostatic shielding. You might be aware of this. So a metal shields the electric field by generating induced charges. Here, induced charges will be generated, because of which there will be no electric field, okay, inside the sphere. So accordingly, region 1 has electric field, 2 also has electric field, sorry, 2 doesn't have electric field, and 3 has electric field. So C option is the correct option. Moving on to the next question. A capacitor of capacitance 90 microfarad is charged by a 100-volt battery. The capacitor is disconnected from the battery and connected to another uncharged identical capacitor, such that one plate of uncharged capacitor is connected to positive plate and another plate of uncharged capacitor connected to negative plate of the charged capacitor. The loss of energy in these processes. Now students, it's very simple. If you know certain things, it's a matter of just value substitution. Okay. So let us derive the formula. I'm going to derive this formula so that later you can use this directly. Now let us see. Suppose we have a capacitor, okay, charged to a potential V naught and having a capacitance C naught, let us say. So what is the initial energy, students? Initial energy is half C naught V naught square. Then you connect this with an identical capacitor. So what happens? They share the charge. So as they share the charge, same charge equally because both have equal capacitance. So automatically the potential difference will also drop because V is equal to Q by C. C remains same for each. So if Q has decreased to half, V will also reduce to half. So the new potential difference between them is V naught by 2. So the new potential energy will be twice of each. Twice of each. And what is the potential energy of each? Half C naught into V naught by 2 whole square. So this 2 gets cancelled. We are left with C V naught square by 4. So as you can see, this is the initial potential energy, whereas this is the final potential energy. So the difference in energy is the loss in energy. So what will be lost from 50% if you deduct 25%, you will be left with 25% of the initial. So as you can see that energy loss will be initial potential energy minus final potential energy, electrostatic field energy of course. So this is C naught V naught square into half minus 1 by 4, that is C naught V naught square by 4. In other words, it has lost half the energy, you can see. The capacitor loses half its energy. So this is a fact. You can always memorize this concept so that straight away you can apply them. Now, what is C and what is V? That's what we have to know. So, if we can find out the initial energy, half of that. So, C is this much, V is this much. So, substituting the values, we have 900 micro stands for 10 power minus 6. Voltage is 100, that is 10 power 2 whole square upon 4. Okay. So, this will be 2.25. 9 by 4 is 2.25 into 10 power 0 because total 10 power 4 and 10 power 2, 10 power 6 and 10 power minus 6 will become 0. So we have to express in terms of 10 power minus 2. So let us multiply and divide by 100. So you multiply by 100 and at the same time divide by 100. So this is the answer. So correct answer is 225 into 10 power minus 2 joule. Right. Moving on to the next question. As shown in the figure, a cuboid lies in a region with electric field vector E equal to this much. The magnitude of charge within the cuboid is n epsilon 0 coulomb. The value of n is. Dimensions of cuboid are given. Right. Now we have to use Gauss theorem. Okay. Gauss theorem simply states that if you can calculate the total electrostatic flux, that is total flux through a closed surface, that is Gaussian surface, then it has to be 1 by epsilon 0 times the net charge enclosed within it. Enclosed within it. So first thing is we have to find the total flux. As you can see, the x component of electric field is a variable. So accordingly what we can do, we have to find the electric field here in this phase and in this phase. So that we'll add them to get the total electric flux through these two surfaces. So here x is equal to 0. Remember, the x component of electric field is 2x square. 2x square. So here x is 0. So here electric field is 0. And here, as you can see, x is, I'm sorry, this is y axis. I'm so sorry, students. I'm sorry, this is y axis. So accordingly, we have to proceed. X means like this. This is the front face, this is the rear face. So here electric field is 0, whereas here the electric field is, if you put x equal to 1, you get 2 into 1 square, that is 2. I hope everything is SI in SI unit, so no need to worry about the units. Okay. So total electric flux through this phase and this phase will be, I'll call this as phi x. For this it is 0 because electric field is 0 here, and for the front face it is 2 into E into A, because electric field lines are absolutely perpendicular to the surface, perpendicular to the surface. So cos 0 will be 1. So what is the area? This length is 2, whereas this height is 3. So 2 into 3 is 6. So this is 12. Similarly, along the y-axis, it is negative. Be careful, it is along the negative y-axis. In other words, the field lines are like this. Okay. So again here it is 0 because y is 0 here. Whereas here, this face, I'll mark it with yellow color. This face, electric field is, put y equal to how much? Y equal to 2 you have to substitute. So minus 8, because they are entering, lines of force are entering. So flux, total flux will be again 0 due to this, and minus 8 into area. What is the area? Area of this is 1 into 3. 1 into 3. 1 is this and 3, this is 3. So 3. So minus 24. Coming to the flux associated with these two phases, that is the bottom phase and the top phase. You can see the Z component of electric field is constant. And if electric field is constant, that means equal number of lines of force will enter as well as exit through the along the z-axis, that is perpendicular to these two faces marked green. Equal number of lines of force, whichever line happens to enter this, the same line will come out. In other words, total flux entering is equal to total flux coming out. Now as you know, flux entering is taken negative and flux coming out is taken positive, so equal and opposite is 0 total. So therefore, I'll substitute here. Total flux is 12 minus 24, that is minus 12, is equal to net charge to epsilon 0. So net charge is minus 12 epsilon 0. We have to find the just magnitude. So drop the minus sign there. Okay. If we have to find the magnitude, drop the minus sign. So n is how much? N is 12. Moving on to the next question. Yes, we are done with all the questions here, students. Thank you for watching my channel. Kindly subscribe to my channel and hit the like button. Thank you so much.